Welcome, everyone. We've made it. We're here on the final session of Cisco Live. Really happy you all are here today. I know it's been a long week for me. I'm sure for you all as well. Everyone has their suitcases probably ready to get home. And as you can see, we're talking about a pretty simple topic, right, for the last session. No, I'm just kidding. But no, we're in the session called Automating Diverse Multi-Domain Networks End-to-End. My name's Chad Hill. I'm a customer delivery architect with our CX organization, and been a CCIE, been doing networking for quite some time, supporting US public sector customers. So we have a lot of different personas and environments, enterprise customers operating service provider environments, as well as their own data centers. So a lot of multi-domain architecture that I specialize in working customers in this journey. Been doing the automation thing since about 2016. So been doing it for quite some time, have a lot of good lessons learned. Been working with these customers through this journey, successes and failures, and working in lab environments, from trying to build the coolest thing and trying to launch it into production, and then, taking multiple potential years and getting stuck in labs. So really the session was inspired by a lot of the things from an architecture view and a network engineer view that I wish I knew when I first started going down this automation path. So really hoping you get something from this. And yeah, we'll go ahead and dive in here and talk about some of the design patterns and things. And there's a product called Cisco NSO, or Network Services Orchestrator, that we'll talk about how we leverage that to help customers with their automation journey. All right. I promise this is the final time you'll see this slide. But no, in all seriousness, I'll be in the room after Cisco Live. I know everyone's probably heading to the airport after this. Please join in there. I'll continue to be in it if you have any questions. I know this is a journey for a lot of us, and there's a lot of folks here that are dedicated and interested in this topic. So I have some reference links as well, and some labs and things, even some non-technical stuff that I think are good reads for you all. So please join that room. All right. So for today's agenda, first we're going to really define, I'm sure everyone saw the title, well, what do you mean by diverse, right? So we'll kind of get on the same terminology here and define diverse networks and some of the challenges we see around it. And then we'll get into, how many of you have used Cisco NSO in here? Network Services Orchestrator. Okay, about half the room. Yeah, so Cisco NSO, we'll go into that and some of the key features and capabilities that help us drive simplification for multi-domain automation, especially in diverse environments. We'll then talk about this concept of services and service-oriented design and some of the concepts around abstraction and how we can simplify the complexity of diverse environments using these different design patterns. I'll then walk through some real-world use cases that I've worked with customers, and we've deployed it in production at mass scale across different environments. And these are really key design patterns that I think are important, and I know network engineers are really in the best position to help with the data models and how we look at the network and provide services. And I think, for the network folks in the room, you're in really good position to really drive automation, especially for your organization. And then finally, we'll go over some quick operational use cases. I won't go super in depth, but I just want you to know they're out there. And these are all things that we've launched and done with production for operations teams. And then we'll go ahead and close out. And if there's any questions, I know this is a 60-minute session. If there's anything related to the content, I'll take some pauses and see if there's questions there. We are going through some design patterns that aren't quite fully published out there. Like I said, this is really a lot of the things I've learned over the years. But if not, you can meet me at the end. I'll hang around and talk as well. So, all right. So first off, I want to start off with an analogy. And ever since I was a kid, I was always super fascinated by concept cars. They would launch, they would come out, and they looked, futuristic, and they were there to really inspire you, right? You'd look at them, you'd see the thin mirrors on the side, and then the big scoops, and then all the technology that was packed into it. And it really showed what was in the art of possible from a technical engineering standpoint within the car industry. But like we know, we see the production car come out, and it looks a lot more refined and a little bit different. It's for reasons that we have to consider when they're looking at manufacturing in the maintenance, the laws and regulation to ensure that it meets road and safety standards, the actual maintenance or the scalability of it and being able to change out parts, and then as well as the fuel economy, right? We need the aerodynamics and things to ensure we have proper and increase the aerodynamics of the car. Well, we can think of it very similar when we look at network automation, where we can design and think about the most advanced concepts in theory, but we have to be able to bridge the gap, right, of what we think is visionary to what our operation teams can actually drive and leverage, right? The operator has to, and the driver in this case, has to be able to drive the car off the lot and use the technology that they're used to. So how do we build and grow in this journey to where we're not going to a destination, but really evolving our automation and being able to start automating what we have today? And that's what we're going to get into here, where we're going to talk about diverse requirements that really provide additional complexity in how we're able to have full end-to-end automation. So with that, the key goal here is creating automation solutions that teams can effectively leverage. And I know multi-domain automation is achievable, and I'm going to show you today how service-oriented design enables that. All right, so multi-domain, let's talk about domains. We have service provider, campus, WAN, data center, the branch. How many of you are operating more than one domain environment within your infrastructure? Why we're here, right? Most of the folks in the room. Okay. How many of you have dedicated teams to each individual domain? No one. Yeah, this is the convergence of the teams and how we are operating these networks. And unified teams and being able to leverage across all these technology domains, each of them with their own architectures and terminology and features, and bringing these all together is a network engineering feat in itself for operation teams to be able to look at. Automating that puts much more expectations on these individual teams and how we can actually put something in production and actually have our teams effectively leverage it. All right, so another aspect of diverse, right? So we have multiple domains, and then within the trends of fabric-based architectures and dedicated roles and optimizations and hardware-specific performance scalability aspects, we have specific roles that are functioning in ways and potentially multiple operating systems to satisfy those requirements. So not only do we have multiple domains, we probably have multiple operating system across domains and potentially within the domain itself. So that brings me to, what do we mean by diverse with networks? We have multi-domain environments. I have multiple operating systems. If it was a perfect world, we all would have brand new networks, but we know that's not the case here. We have legacy systems with CLI interfaces, SNMP. I was working with a customer. They are still using TL1 on some of their systems. And then we have all the new modern stuff, right? And being able to bridge that, but we want to start automating today. And then on top of that, we have diverse skill sets within our teams and being able to actually maintain all this. And then multiple stakeholders that are all converging together to where we don't see the network as individual networks anymore. It's the network, right? It has to work. All right, so we talked about some of the aspects of what we mean by diverse. I want us to start thinking, and we're starting to do this with a lot of our intent-based driven architectures, but start thinking within this presentation in layers, okay? So we have the physical layer, which is really the devices, the optics, the fiber, and the ports that all interconnect my network, right? Then we have the network domain layer. So that's data center, campus, service provider, where multiple devices are operating as a system to provide services. And then we have the service layer, where we have control plane and data plane and configurations across these devices that provide services within the domain and potentially cross-domain, right? So just keep this in mind, and then as we start going to and start talking about abstraction, these are the layers that we're going to come back to. All right, so a little bit about Cisco Network Services Orchestrator. So Cisco NSO was an acquisition back in 2014, a company called TailF. And they were really built around an automation platform where we have a lot of flexibility to do many different things. And the key thing with NSO is it is multi-vendor. It's a Linux application you install on top, and it's a platform. And how we provide multi-vendor automation is through what we call network element drivers, or NEDs. And what these NEDs do, they're essentially adapters that talk to all these different types of operating systems. We have over 100 types, where they handle all the interactions, the interface type, and the nuances and rollback capabilities. The NEDs essentially provide device abstraction to normalize all the device interactions that we have across these diverse networks and integrate it into what we call the CDB, or configuration database. We'll get into this a little bit more, but NSO has a centralized database. If you want to think of this, all the configurations of your network are stored inside of NSO, and it has an entire view of your multi-domain networks. And then we'll talk a little bit more in depth a little later in the presentation about Service Manager. NSO manages the network with what we call services. So just we don't think of the network anymore as specific interfaces and devices, but it's really configurations that potentially span multiple devices to create a service. So we're managing the network in this service type of construct. We'll get into that a little bit more. All right, I think everyone's probably familiar with Yang in the room. Yeah? Okay. So yeah, just for those who are not familiar with Yang, essentially it's a RFC standard. It was built around for data modeling of configurations. As we know, back then we had SNMP. It wasn't really great at modeling network configurations and doing configuration management. So everything inside of NSO is all represented in Yang. As well as we have different IETF data models where there's standardization efforts. And the example you see here is an RFC standard where they try to create a standard data model around an L3 VPN service. So we have standard models, and then we also have open config models, which was really focused around how we can provide a unified configuration model across multi-vendor devices, right? And then inside of NSO, we'll get into it about service models, but you can build your own custom models as well. And what I would say between all these different models, it really comes down to your operator experience, right? What do you want them interfacing with? What data models you want to use? What terminology resonates? So there's no right answer here, but you do have multiple models that you can leverage within inside of Cisco NSO. And it's hierarchical. It's pretty easy to read, and we allow multiple data typings. And the key thing with Yang, it's very powerful in the sense, as you can imagine, the whole CLI config, there's a lot of constraints, right? Like router BGP, if that's enabled, then I want to ask for these specific things. Or if this is enabled, then you must have this. So we can enforce business logic through the constraints, the unique elements, strict references, and then we also can do conditional statements as well. So just keep this in mind. We have a lot of tool sets inside of Yang when we do data modeling that allows us to enforce business logic, so when operators are selecting different values, we can ensure that it meets the intent that we're looking from a organizational standard. All right, so for those that use NSO in the room are probably familiar with this, but you heard me talk briefly about the configuration database, or the CDB. NSO is a stateful automation tool, meaning that it has all the configuration state of your entire network in the CDB. So just so you know some of the moving parts, we have C, which is the device configuration itself. The first thing when I onboard a device in an NSO, I do a sync from, and that pulls the full configuration inside of B within its centralized configuration database. And then I have services or templates that I can apply to that. So the key thing here that network operators really appreciate is I have full visibility of all my configurations in the network, and with a stateful engine, I can preview changes by doing a dry run and see the configurations before they actually push. It calculates the delta before I actually push it, so I know what's actually going to change on my network, and that's really key to building trust with our teams, especially when we talk about network automation. And then, of course, the CDBs, certain operating systems don't have built-in rollback capabilities. Well, you have it with NSO, right? Because it has your whole configuration state. So if something goes wrong, you have native rollback capabilities there. All right, any questions so far? Good, tracking? Awesome. Okay, so now we're going to go, question here, yes?
Thank you. How would you use this data, the difference on the configuration when you are reviewing a change?
We'll get into that in a little bit. Yeah, let's go through the examples, and then I'll come back to that question if it's still there. Thank you. All right, service-oriented design. So I want us to put us in the mindset of a network engineer. And this is literally when I first started this automation journey with customers, I would sit down, and this is the evolution of how things started. And this could really apply to any tool outside of NSO, right? All right, so when we initially get into an environment, and then we see, okay, what patterns do we have around our configuration baselines? Do we have configuration standards? And then we quickly start to find out that, hey, these device roles mean something, right? For instance, my access switch is only at layer 2, so I only have specific features and configs that are standardized for that switch. My core switch might terminate on my layer 3 connection, so BGP, OSPF, or whatever protocols that I use on my core belong there. And then we have all these other roles across the WAN, whether a PEMP router or spine and leaf architecture within the data center. But these device roles mean something, because there's a set of configuration standards that apply to these device roles. So as we start identifying these, and if we didn't have standards, we start creating them, we started using Excel sheets, right? We define these standards, and what we do is we put the configurations and each point in network or pin or device type or role. We then create a tab for each device type. So I have an access switch with OSA, a campus router with OSB, maybe I have another operating system of a same campus router, but it's a different configuration format, so I store that in another tab. And then I start to variabilize everything, right? And then, typically what we do, we hand it to the network operator, and then they, put in variables into it, and then they copy and paste the configs, and then hope all is well. But we know the network engineer, these aren't just variables, right? There's actually logic that we build into the variables that they must meet our network standards. For instance, I might want to embed the site name within the host name, so when I quickly look at the host name, I know what site it's in. My TACAC servers, maybe I'm operating across the US and I have an East Coast and West Coast server, and I want geographical redundancy, so you have to make sure you point to each of those IPs. And then my loopback, I might embed concepts such as region, site ID, device ID, so when I'm doing troubleshooting, I know exactly where it's at, what site it's in, and I'm able to have traceability to the location. So what do we mean by services and service-oriented design? Well, in the context of networks, a service is really a function or capability provided by the network, where we have configuration sets across many different devices to provide an end-to-end service. So in this case, I might have a router and a firewall, and then there's service instances for maybe I'm doing on a per tenant basis or whatever my segmentation policy is, and I create multiple instances, maybe an employee group or whatever construct that you're building. And then we have what we call the service data model, which is really, if we think about that Excel sheet, is the representation of my service to a northbound system or an operator. And the data model models all the key value pairs that I need for input in order to create this service. So we'll get into an example of that, but think of like an L3 VPN. I need to ask for maybe a route target, the interface, what protocol you're using, right? But I'm only going to ask for the variables that I need in order to instantiate the service. So that's what a service construct is when we talk about data modeling. So how do we think about the network? From a network engineer point of view, we're probably going to start maybe from the bottom, potentially, where I have the features, the configurations, the network elements. When I come into a new job or role, that's the things I'm quickly learning. And then from there, I have the services and the domains and systems that are created to provide whatever service capability you're offering. And then from a higher level, from whether it's the CTO or whatever, we're thinking about the network as a business capability providing a certain outcome, right? So we could think of the network from the top down, which is more from a business point of view that then are requirements that get fed into services, or from the bottom view of how the network creates these services from the bottom up. This will make sense as we get into some of these examples here in a second. All right, so we have our network engineer, right? And there's some new requirement where we need to spin up a new employee group A. So the business requirement comes in, they're starting, and the network engineer receives that requirement, and then they have to determine, well, for this new employee group, I want to segment them. They're going to need a new VLAN, maybe a new subnet. And so my network services, I'm going to need a new L2 network as well as a L3 network to create this service. From there, the network engineer then determines, hey, I need to provision my L2 network on my access switches. Here's the set of configurations I need. And then for the L3 network, I need to provision that on my core, because that's where I terminate L3 services in this case, to provide the new, to create that service across these places in network. Finally, we then determine all the features and configurations needed to construct these services, and then determine the final configurations with the variables I'm going to push. And then if I have multiple operating systems, especially in diverse environments, there's maybe potential different interfaces and ways that I have to apply this into the network. Now you can see from a service-oriented design how multi-domain networks, the complexity grows. The amount of decisions we have to make from the business requirements coming in. From the campus, it's a new employee group. From the WAN, I have a new VPN service. And then from my data center, maybe it's a new application segment that I'm spinning up. And then we have the services that represent those, and then all the decisions we have to make across these device roles, and then my device models and configurations that need applied to all these individual devices. So with that, going back to NSO and how it's helped us here is it provides abstraction. And what we mean by abstraction, we have our business services, our service abstraction, or the representation of how I communicate this service to a stakeholder, and then I have my device abstraction as well. NSO, with service packages, models the data and hides the complexity through the abstraction of NSO service packages. And then what the network element drivers do, or the NEDs, provide the device abstraction, so they provide me a consistent way of programming the network and handling all the OS-specific interactions. You know, every vendor has different maybe commands to commit things or apply, and then the error handling. The NEDs take care of all that. So now I have a consistent interface to maybe a northbound system, or in this case, when we're initially starting, my operator, right, and how I manage automation across the network. So one of the key values here that we see with NSO is it has a CLI interface. And you're like, man, I feel like we're kind of going backwards. It's really a CLI interface of doing automation across the entire network. And why we see a lot of adoption is because it's an interface that's familiar to our operators, that they can then configure these entire services across my entire network through interfaces that are familiar to them. We also have a web UI, and then we create all these automation assets and use cases. And as we evolve and we want to do system-to-system integration, all those automation capabilities and data models that I create are automatically rendered through the northbound API. So everything you do in the CLI has an API. So maybe it's a new workflow orchestrator or some system on top. We can directly call through these APIs and automate that process. And then from a programmability standpoint, we have Python and Java APIs.
When you say Python APIs, do you mean like libraries or something like that for it?
Yeah, so the question was, Python APIs, do we have libraries for it? The answer is yes. NSO ships with anything that you have, all the data models and devices and its configurations are auto-rendered into a Python API, so you can write your own Python against the API, and it essentially abstracts and provides ways to configure the network through Python. Yep. All right, so getting to some real-world design patterns. And we're going to put this all together, so we're building here. So, you know, we start with the network engineers, and the first thing we do when we start this journey is we start to define my baseline standards and configurations. I'm going to try to build out a source of truth with my variables, and we're going to define some operational processes, and I'm probably going to start that on a per-domain basis. That's what we refer to as day -1. So we refer to these use cases in days, and then that tells us the end-to-end automation from planning to actual services. Day 0 is what we refer to as the zero-touch provisioning use case. That's initially plugging in a device into my network. It bootstraps itself. It might upgrade its operating system. We onboard it into controllers. Day 1 is now that device is onboarded, I have my golden configuration standard that I need to apply to this device so it has connectivity to the rest of my network. So that could be all your management, your interfaces, and core configurations. These are things that are getting it ready to set up for network connectivity and services. And then we have day 2, which is then the services that provide the end-to-end connectivity for my end users or devices. So in this case, we're doing full lifecycle configuration management. This is the churn, right, where we might be spinning up new VLANs and SVIs, or maybe it's L3 VPNs and L2 VPNs, or it could be new VNIs within a VXLAN fabric, right? This is the churn as we spin up all these different configurations to create services, which we refer to as day 2. All right, so NSO service packages, we talked a little bit about this. The key thing with service packages and examples could be L3 VPN, golden config, port turnup. There's many different use cases we can apply here, but essentially has a service model that represents all the input variables that I need to ask from an operator to instantiate the service. Then I have some code and what I call the secret sauce fast map, which is an algorithm where update and delete are really hard, right? Especially when we're trying to calculate changes in the network applying configurations. What FastMap does is we only need to tell NSO how to create something. And because it has state within its database, it actually can automatically calculate the updates and deletes needed to actually stand up and turn down these services. So if we think of like normal scripting where it's stateless, we're going to have to code for every single example and error handling depending the device state and where it's at. Since we have all those device configurations, we can calculate all the changes automatically. And through our configuration templates, we only have to tell NSO how to create something. So this is what a service package is deconstructed and looks like. So all the way on the side, we have a service data model that represents all the key value pairs and variables that I'm asking for my operator to input, all the different parameters for my service. I then define different templates. In this case, I might have a QoS template, BGP, or interface. So let's say this is an L3 VPN example. And then my device data models is the device configuration represented inside of NSO's database. And then I have the device config that then actually gets pushed out to the network. So when the operator inputs these values, I type commit. I could run some code, and maybe I want to take a variable and derive more variables. So there's Python and Java here that we can manipulate the operator input or maybe a northbound system input with other values. Based on those inputs, let's say they chose PECE protocol of BGP, and they inserted a CIR for QoS values. So I'm going to select my templates based on the input values. Then I do parameter substitution into my templates. That then does the apply where FastMap, we just told it how to create. It's going to automatically calculate the diffs based on the device data model or the configurations in the CDB. And then it's only going to push the configurations needed on the device because we have state, right? We're not going to push the full entire configuration if we don't need to. We're only going to push the changes we need. And like I said, the network engineer's best friend, when you got to push the button and do changes, don't forget about dry run. I can preview the changes in a native output format and see the no commands or the actual commands it's actually going to push line by line, so I can validate it and improve it before it actually goes into the network. Did I answer your question? Awesome. Thank you. All right, this isn't commonly talked about, but I think it's super important and it can resonate with network engineers because it follows patterns that we naturally do day to day, whether we realize it or not. So I want to talk about data relationships and data modeling and how we can do business logic to ensure that we can enforce standards in our network when operators put things in to ensure it meets what we need. So this is what we call, I call the stage and deploy. And in this example, I have maybe an inventory data model where I store all my inventory variables. In this case, an SMP server. And I'm going to go ahead and change it from 10.1.1.1 to 10.1.1.2. We typically have patterns in operations where I want to stage something but not push it yet, right? So we have a stage deploy model where we want to do a two-step process. So we go ahead and update the SNMP server to the new value. I then have my service in this case that's configuring my SNMP server on the devices. And what I can do is then read that value, and when I do a redeploy on that service, which is essentially pushing the new configuration based on the new values in my service model into the network, it'll allow me to do it in a two-step process. So the service data model reads the new value, and then it pushes it into the network, and then it allows me to have this stage deploy effect. All right, strict reference. No worries, you're good. All right, so a strict reference is, we're in the same example where I have an inventory data model and I want to roll out my new SNMP server. But I only want operators to be able to select the valid SNMP servers that are in my inventory. So in this relationship, I have my same service that's configuring my SNMP server, and it has what we call a leaf ref, which is in Yang. And that's a strict reference to a value from another data model. So in this case, the operator can only select the new SNMP server if it exists in my inventory. So they can't go and push something into a service, into the network, if it's not validated. And these inventory models are probably your subject matter experts that are validating these are correct values to use. So then it does the validation, and the operator wouldn't be able to input it if it didn't exist. And then we can see it's there. So when we do the validate and I do the commit on my service, it'll then push it into the network. All right, finally, the last example is what we call stack services. And this is very unique to NSO. All those other examples you could do with just normal Yang. But in this case, what we have is the same example, but now my inventory model is also a service. So it has fastmap. Remember how we talked about it can create things and we don't have to tell it how to update or delete. In this case, it's going to write the values to a downstream service or another service. So that's why we call this stack services. So in this case, when I change my inventory data model and it updated to 10.112, it's automatically going to write the value to all my other services that use that value and then push it into the network. So these are really coupled through state, right? So if this state changes, I want the other state to replicate. That might be a neat way, especially if we want just when I do a change for it to just automatically propagate, and I know it's in the network once I do that.
Update a bunch of stuff.
Yeah. So the comment here was there's a lot of planning around these different relationships, and that's a really great point. There is a lot of planning, right? The other scenarios, I'm writing a bunch of test cases and validate that the operator didn't do something. So the patterns here that we see, we're able to actually, network engineers, it aligns to natural patterns that we're doing when we do network provisioning. So we're just mirroring these same exact patterns into data models and how we can align with how operations does these different use cases. So, but yeah, it does take a lot of planning and thinking through, right, through all this.
SNMP or whatever, to be able to go one place and go into that service, and then boom, it goes everywhere. Like, that's freaking awesome.
Yeah, the comment was just it being able to just automatically propagate when my inventory updates across my entire network through that state. Yeah, no, it's really cool. I mean, especially when there's low-risk changes where we just want it all to propagate automatically, right? Yeah, cool. All right, so now getting back to our original diagram of multi-domain layers. So we talked about all these different concepts, and now you see where I'm getting at. We can actually create data models around all these different layers to represent my different information that I might need in order to provision a network. For instance, a topology data model, I know my access switch to my core switch, maybe I have a switch trunk allowed VLAN list that I always propagate something, so I get some topology intelligence based on a topology data model. Maybe it's a domain data model where there's campus-specific variables and data center-specific variables that are modeled that I use across within these domains. And then my service data model, which then represents the actual services that I provision into my network. So it looks a little something like this as an example, where now this really becomes a data organization problem, right? And going back, I'm sure you've heard a lot of talks about sources of truth and ensuring where should I reference for the actual values that go into my network. But the data organization is important because these variables provide context based upon what they're serving. So in this case, my domain or my network, I have individual networks that the network type and device role means something. If we go back to that Excel sheet, that information for the device and its role association tells me configuration sets that apply to that specific domain and role. We then have sites, which then maybe there's multiple networks within a building, and I want to reuse variables across these multiple networks within a site. And then we have global variables, where I want to use these variables everywhere across all these domains within my network. In this case, it might be SNMP servers through the example we just went through. All right, we're going to get through some examples now, and we're going to put this all together. Any questions so far? OK. All right, so here's a use case, what we call a day one golden configuration service. This manages my full baseline configuration to bring up a switch in this example in my network. So we have switch A here. I can define that switch into these data models, right? So I have a network data model that models all my different types of networks. In this case, it's a network called Campus 1, and the network type is campus. I then have sites where I want to track all my devices within individual sites and know where they're at and located. And maybe I have site IDs because I embed that into my loopback allocation schemes. And then I have devices that belong within the site, so I know where they're located. My network campus 1, I can then, in my data model, in this example, I'm selecting my site and my devices. The cool thing with leafref, if we think about this in a CLI, what a leafref does in NSO, I do a question mark and I see autocomplete of all the available options that I could select. In this case, since I have site 1 configured, it's a leafref to site 1, so I can select that for my campus 1 network. And my devices switch A is a device under the site, so it's also a leafref to only select devices within that site. So I'm organizing my data here, right? And we can see it's a core switch. We define it as a core switch, so that means something for us from a configuration standpoint. And then I have my global inventory. So in this case, I have an Americas region and an EMEA region. Each of these regions have region IDs, because I use that in my IP addressing scheme. And then I have my SNMP servers and TACAC servers that belong within those regions. Now I get to my actual service. So all the data values that we provided up top, that's a day -1 activity. I populate, in this case, it's representing a source of truth of the representation of the data in my network. And I can reference that data over and over as I provision services within my network. So my day 1 service, my key of asking an operator, I'm going to ask them, OK, what network do you want? So they're going to select, and they see autocomplete. OK, Campus 1. Campus 1 is the network you selected. And I also have a leafref to select valid devices within that network, in this case, switch A. The human operator experience now is, remember we talked about diverse geographical SNMP servers. So we've abstracted the IPs from the operator input, and we just say SNMP server Americas and EMEA. So what can we derive from this? Well, I have a leafref to my regions, so I only could select valid regions. And then I read, right? Remember the data relationships. I read those IPs in order for my service for my variables. So in this case, what can I derive? Switch A belongs to site 1 with a site ID of 99. I'm going to use that for my loopback allocation when I construct my loopback address. Site 1 is also in the Americas region. I have some policies that apply specifically just to Americas, so I know what configuration and templates I'm going to need to push onto this device. And then I can also automatically derive my SNMP servers are 10.1.1.12 and 10.1.4.12, giving me geographically diverse SNMP servers. But you could see the input from the operator, they didn't have to specify all that, right? This is the power of data models and being able to model the business logic and then having organization, so from an operation standpoint, all the complexity is abstracted. right? I go ahead and type commit, my full configuration. I could do the dry run and preview before the changes happen. My configurations get pushed, and now I can see my trunk ports are up, and I'm part of the spanning tree topology and whatever other configurations might be on your core switch. So that's a day one service. That was a top-down view. It's a little bit different way of thinking from an abstracted view. So let's go ahead and think of the bottom up, which is how, me as a network engineer, how I typically think, right? All right, so now we have my new core switch provision, and it's ready in the network. I'm going to have a day two port turn-up service. And in this case, we have campus 1. My L3 is in OSPF area 0 on my core switch, and then my access is a pure L2 switch design. From there, I know when I turn up a new port, in this case, in the example we did, a new employee group A, right? I need to ask for my SVI, a VLAN, right, as well as the new IP address. Maybe it's a helper address for DHCP. I'm going to statically apply the OSPF area or OSPF1 area 0 and an ACL because I don't need to ask for that input, right? Those are standards that I'm going to always apply to every single SVI. And then I have my access switch port, which I ask for the port name or port number that they're connecting to, the description. In this case, it's the group or the employee group name and the endpoint type that I'm going to concatenate into a description. And then I only need to ask for the access VLAN value. I don't need to ask for all these other .1x parameters because those are static configs that I'm going to put on every single port for port security. OK, so this is what my service model looks like. So I've created what I called an L3 tenant service. So the L3 tenant service, they can select valid networks, right, because we're across multi-domain networks. I have employee group A, so you're selecting the employee group you're actually provisioning. And then I'm going to provision this on switch A. I then ask for the VLAN information, the IP addresses, and then the access switch, and then the ports that I need to connect this actual employee group. So I'm only asking for the variables that I need in order to instantiate the service across many different devices. I don't need to ask for all these other configurations, so we're having some config compression here automatically through NSO service packages. But wait, my core switch is the only one that terminates the L3 interface. So what can I do with data modeling? Well, you only could select valid campus or valid network, so I'm going to make it a leaf ref to a network. Then we have the selection of which switches, but I can do a must statement in my Yang model to say you must be a core switch in order to select this. So when the operator does a question mark, they're only going to see the core switches. So there's no error of accidentally putting an access switch and pushing your L3 interface on the wrong device. And then I have a leaf ref to my tenant inventory potentially where I'm storing all my tenants that belong on that I'm going to allow the operator to select. So you can see here we're aligning the service model to operations and having that service level experience. So in this case, this is a CLI config. An operator can go into NSO and commit, and it's going to push all those changes in. But then from a northbound system, I can do that same payload from any northbound system, or I can use Ansible. We have modules that can automate this process on top of NSO. And so you could do many other different use cases without interacting directly. We're just bridging the experience of our teams into this automation journey. All right, so real quickly, so operational use cases. So we've gone through day one and day two and how I turn up a new device and provision services. I'm not going to go in detail on these. These are just for reference. But in this case, we have features inside our devices called zero-touch provisioning. And this helps with the day zero use case where I can pull my initial management IP, bootstrap the initial OS and management configurations for initial connectivity, and then I onboard it into the controller. And now I'm ready to actually do some provisioning. So one cool thing that I found within these environments, we don't always have devices that support ZTP, especially in diverse environments with legacy devices. So NSO has this feature called remote proxy. And what this does is the NED can use a jump host or proxy server to configure another device. So in this case, I might have a terminal server still that connects via console, and I can use the terminal server as a proxy and apply that initial configuration onto the device via the console. Once it has management reachability, I can then switch to its management IP and then onboard that device into NSO. So these are some unique use cases, especially in diverse environments where I might not have ZTP support in all my locations. NSO actions, if you want to think of this, we talked about services, and that's managing configurations. Actions is like an RPC, where we have input, we have tasks that we perform, and then an output. So in this case, you could think of like, I want to drain traffic, and I put certain configs in order to make sure I can drain the traffic off the device. Port migration, connectivity check, maybe I'm checking BGP neighbors. NSO actions you can create, and it leverages Python in it, where you can do multiple things through the Python API. So with NSO actions, one of the cool things that we've worked with a lot of customers is, hey, I need to deploy this whole new network, and I need a migration. What we can do with NSO, since we've done the abstraction of the devices and the services and configurations, I can save all those, I have all my data models there, but I can read my existing production network, abstract and pull out those key value pairs and parameters, and populate it into my data models. From there, once I reconcile all my data from the production network, I can then use my services that then push the same key value pairs into this new operating system, in this case OSB. Hopefully you're moving to a Cisco box, but I can validate it in a staging area and then have high confidence I can deploy it. So this has helped us with de-risking things, and through the abstraction, being able to port from one operating system to the next. Which is pretty cool. It's helped us accelerate things. This is another use case. As we evolve things, I had a recent customer, they're like, hey, great, we've automated our production network, but what about pre-prod and my dev process? And we're starting to use GitLab and these different CI/CD processes for my life cycle of my services. How do I integrate that? Well, the cool thing here is since everything's abstracted, and through the device abstraction, the NEDs can go across both virtual and physical devices. So I can set up NSO and leverage these same automation assets across my lab, pre-prod, and prod lifecycle through the full process. So I've automated the day 0 process, the day 1, turn up of day 2 services, run my test traffic over the network, and then I'm going to have a consistent way of then doing from pre-prod to prod and doing that deployment process. So this is really more of an infrastructure as code type approach. And like I said, all those APIs are available. You can trigger and call NSO through like Ansible from a pipeline. So there's a lot of cool use cases here. All right, this is another one. So one of the things with legacy devices is, and it's only accessible via CLI potentially, is that data is unstructured, right? The operational data. If I move to netconf devices, obviously that becomes a structured data, and I could do a lot of cool things with it. But in this case, in my legacy diverse environment, I have operational data that's unstructured. With the actions, in this case, a BGP test action, I can leverage, I won't get into detail, but PyTS is a tool for Python test automation that Cisco has published out there for customers to use. And it has a library in there called Genie. And what Genie is a parser to parse unstructured data into structured output. So what we've done with customers in this case is I can use the Python library of Genie in my action. And as it uses the NED from NSO to pull that unstructured data, it uses the Genie parser, and then I have structured results. Now I have JSON. Now I'm cooking, right? I have validation code, and I can validate this data in a consistent manner. In this case, we have a BGP neighbor state, and it's idle, and then I can return some output to an operator and said, yeah, this test failed, right? So there's a lot of cool customizations and operational use cases around operational checks. All right, so this is another one that is very common, especially in these multiple operating system environments, is how do I provide a consistent way for OS upgrades, right? You know, I'm not going to get into all these steps here, but we have pre and post checks. Then I have some operation I do in order to upgrade the operating system. One thing that we've done with NSO in doing operating system upgrades across these environments is it simplifies and abstracts all the device complexity and nuances of executing all these commands and configurations. So through NSO's API, it simplifies the workflow on top, because if I'm doing configurations, I don't have to code the update and deletes. And then I also have a consistent API that pulls data in to do my checks and validations. So in the case of diverse networks, we have, and NSO, I have automatic rollback. So if my OS upgrade doesn't work, we can use NSO to roll back to a previous configuration state if I drain traffic, as an example, right? One key thing is NSO is atomic in nature, so those service constructs, if I configure 5 devices and the 5th device fails, NSO is going to automatically roll all that back. So when I type commit and it's successful, I have high confidence and integrity that that configuration exists in my network and I have true state. And so if we think of multiple baselines and revisions, right, and I'm using a stateless automation tool, I don't know what version my network's on. I have to go run something and check what it is, but in the case of NSO, I have that transactional integrity and atomic nature to ensure consistency. All right, we're coming to a close here. I know that was a lot. We put a lot of these cool concepts together, a lot of things that we've learned over the years. But in summary, you know, where do I start? Because, you know, like I said, and I started, I've worked with customers, and we've been stuck in lab environments forever because we're just overwhelmed by the multi-domain diverse requirements. Day 0, maybe I have limited smart hands that can go to sites, so I'm going to focus there to streamline the onboarding of devices and deployments in the field. Day 1, maybe I'm having challenges around standardization of my configurations and consistency, so I want to create a golden config day 1 baseline and automate that process. As configuration drift happens, that state, we can automatically go from baseline to baseline. And then day 2 services, right? I need speed to market. I have multiple customers turning up and turning down, or endpoints, or whatever you're servicing. So maybe I'm going to start there. And as we know with configuration churn, this is where most of the human error happens, right? You don't have to do all these at once. You could pick one and move to the next one, start small, find a good use case, and then expand from there, build the confidence with your operation teams. All right, so we started, oh, question.
Actually, I was just going to ask, does a NED exist for ACI, NDFC, and Catalyst Center?
Yes, so there's a question about NED support. We have over 100 NEDs. A couple of them, like ACI as an example, we have NEDs for. We can talk offline. Some of them are proof of concept NEDs, so if there's a demand or use case, I work closely with this business unit. They're very good at, these NEDs are fast to develop, and NSO or Cisco maintains them and then provides them to you based on what configuration set you're looking at. So. All right, so we started this conversation with the concept car. And you know, like I said, I'm inspired by concept cars, but when I go on road trips, I choose the minivan. And you know, working with these customers, going in this journey, multi-domain automation, especially in diverse environments, I know are challenging, right? But I know multi-domain automation is achievable, and service-oriented design really helps our customers in being successful. So with that, I have some resources for you. You can download NSO for free as a copy if you want to try it. But these concepts apply to any network automation, right? It's really a data organization challenge. So please, leverage these concepts with any tool you use. This is network automation delivery model. It's a non-technical read. If you're looking at building an automation team and how I develop my organizational maturity and go down that path, this is a really great read for you. I have it in the WebEx room. It was put from lessons learned from all our customers at Cisco and put out some best practices there. And with that, I appreciate if you guys do your survey. Like I said, I'm passionate about this topic. Give me feedback, any thoughts. This is the first time I've seen these concepts put out there, but I know they're out there, and a lot of presentations say, go do this. It's like how I do it. Well, these are my experiences since 2016. But hope you all have a great travel home. Hope you had a good time at Cisco Live. Thank you for being here with me on the final day, on the very last session. Safe travels, and thank you, everyone.